Quiz time. What do the native applications for Discord, Slack, Dropbox, Figma, Spotify, and VS Code have all in common? The answer is that they are all built on top of a framework called Electron. Web applications we're taught to make in this course are great. They're generally considered to be easier to learn and allow for rapid prototyping and debugging while enjoying cross-platform compatibility thanks to their wide standardization and their interpreted nature. But because they run in a virtual sandbox environment within browsers, they're limited in other ways. For one, they're slow, kind of. They also need an internet connection, kind of. And they also have limited access to the host machine. You can forget about accessing the shell or any file system operations from your web application. Native desktop applications differ from web applications in that they run closer to the host machine. The trade-off is that developing for them takes a lot of developer effort. You'll probably have several teams implementing the same features in several different code bases. Say one for Mac written in Objective-C and another for UWP-based apps for Windows. Wouldn't it be great if there was a way to use web languages and tools to develop native desktop applications? This is where frameworks like Tauri and Electron.js come in. These frameworks allow you to deploy native desktop applications for Windows, Mac, and Linux using web languages like HTML, CSS, and JavaScript. In this video, I'll be primarily focusing on Tauri, but it is important to note that Electron is the much more mature framework here. Of course, it also has its advantages and trade-offs. As we go along, I will sometimes compare Tauri with Electron to highlight the differences between the two. So, how does it work? Electron essentially bundles a Node.js environment, as well as the Chromium browser, which a lot of other browsers are built on top of, including Chrome, alongside web application code. As you can imagine, this results in large binaries that consume a lot of memory. Tauri handles things differently. Instead of bundling the entirety of Node.js and Chromium with every application, it uses a Rust backend with a cross-platform and lightweight window manager in Tau and WebView rendering library in Rai. This results in smaller app sizes, where I've had 110 megabyte Electron apps come down to about 4 megabytes, and Tauri also consuming much less memory when compared to Electron as well. On a side note, Tau and Rai are upstream dependencies of Tauri maintained by the Tauri developers. Although I won't get into too much detail, Electron essentially concatenates all assets and source code together in an ASAR file, which itself is essentially just a tar file with a few additions. It is also easy then to unconcatenate these files and get all your assets and source code back out. This process is called decompilation, and it can be a very bad thing for production apps, both for security and IP reasons. You can encrypt the ASAR file, but of course that comes with its own trade-offs. Because Tauri compiles everything into a binary instead of relying on a tar-like archive like Electron does, it is much harder to decompile your Tauri application from the get-go. But that's enough theory. Let's see how we can actually make an existing web application a native one with Tauri. Here I have an existing Angular web project. Don't worry if you're unfamiliar with Angular, this demo's focus isn't on the web part. In fact, Tauri doesn't really care about what framework you use. All Tauri cares about is the final minified bundles, and not the source code that created them. For reference, the web-only branch contains the basic Angular application. npm install, then npm on start as usual to start the app. And the app is pretty simple. So the app starts with Ferris, the crab, asking the user a question: C or Rust? Ferris, being the unofficial mascot for Rust, obviously has a preference for Rust, and Ferris will be happy if the user answers Rust. Look at him go. But if you answer C, you'll be angry. That's the premise of the application. So how do we make this a native application with Tauri? First, we should get our dev environment set up. Tauri depends on a few different things depending on your OS. Follow the link in the README here, then follow the instructions for your specific OS. I'm on Windows 11, so I'll need Microsoft Visual Studio C++ build tools, and also Rust as my dependencies. If you're on macOS, follow these, and if you're on Linux, follow these. You should also make sure whatever terminal you're using can find the Rust binaries before continuing. You can verify this by running rust c and ensuring the help text prints. If it doesn't, try a restart, or a neat trick if you're using VS Code is to start VS Code from a terminal which can access Rust C. So this one can, and I'll just start code with this, and VS Code terminal can also access Rust C. Now let's install the Tauri CLI by typing cargo install Tauri CLI. Cargo is the package manager for Rust. It serves essentially the same purpose as npm, but for Rust packages. Once you're set up, type in cargo Tauri init at the root directory of your ongoing project to make it a native application with Tauri. It'll ask you some setup questions like what's your app name, what's your window title be. Ferris is fine. Where your app asset's located, it's at Ferris. URL of dev server, npm run start, npm run build. Cool. And it's as easy as that. It'll create a source Tauri folder where all your Tauri-based files are based. One more thing before we can compile, go to the newly created tauriconf.json file and give your new Tauri app a unique identifier. So I'll just call mine com_example.ferris, and that's it. You can compile your binary with cargo Tauri build. It'll go through your standard browser setup and it'll start compiling the app. And at the end, you'll get both an installer and the exe itself. There we go. You can find your installers here, or you can also come to target release folder and click on the exe to run it directly. And here it is. You can see that the functionality is all working good. Tauri employs a multi-process architecture, very similar to modern browsers. On a quick side note, processes are independent programs with its own memory space, code, data, and resources that are managed by the OS. Similar to browsers, which maintain a separate process for every tab, every Tauri application has a core process, which can be seen as the organizer or the core process. It has full access to all OS features and manages the web view processes, while the web view processes are responsible for actually rendering the application, essentially your front end. This helps isolate the web view processes from the OS as well as each other. Not only is this good for robustness, by that I mean a crash in the renderer process doesn't necessarily mean the entire app has to crash, but it's also great for security, which Tauri is very big on. Because the memory spaces are separated, the risk of any given renderer process being able to snoop around in any other process's memory is quite low. However, because they are separate processes, we need to use inter-process communication to pass messages between our front-end web application and the back-end Rust code running the core process with the access to OS APIs. Specifically, Tauri uses the asynchronous message passing model. Events can be used to send one-off notifications, and commands can be used for request-response loops between two parties, essentially a web view and the Tauri core. That may sound scary at first, but remember, that is almost identical to our client-server architecture that we use in web apps, just with HTTPS as our protocol. This is also pretty much what Electron does as well, with, of course, the Rust backend being replaced with Node.js runtime. Because Tauri version 1 uses JSON serialization for the message passing, you will need to make sure your messages are JSON serializable. In version 2, which is currently in beta, JSON RPC has been replaced with a custom protocol, so you hopefully won't have to worry about this as much in the future. To help us understand a bit more, let's extend the current implementation of Ferris the Crab. So right now, Ferris's thread falls a bit flat. To really scale the user, we'll hold one of their files or directories hostage. To make sure the file is theirs, we'll only target files in their home directory as well. Now, we can implement this in two ways. First way involves the front-end JavaScript APIs that Tauri exposes. Here, getRandomFileFromHome uses two Tauri APIs. homedir, which gets the user's home directory path, and readdir, which reads the directory contents. Because Tauri is quite security conscious, it employs the principle of least privilege. We need to explicitly allow the use of these APIs by going to tauriconf.json and putting them in the allow list here. You can see that I've allowed all APIs from path, I've allowed readdir from file system, and I've also set the scope of access, so essentially what the renderer process can read from the file system, to only be the home directory. It can't access anything else. Running the app with cargo Tauri dev, and picking C, we can see that it correctly gets a directory from my home directory. In this case, it's threatening to delete my .NET folder, which wouldn't be great. The second way involves writing our own custom Rust backend functions and invoking them from our frontend code. Here, we see that getRandomFile from home has been replaced by the invoke command. When this is executed, the corresponding backend Rust handler will be called. Here we are in main.rs. This is actually the entry point of our binary, and we also see the handler for the invoke command getting registered right here. You can see that it generates a handler, this is a macro, from this function. Don't worry if you don't understand this. The important thing to note here is that we do not need to explicitly specify which files this backend function is allowed to access. That is because this function is being run on the core process. Of course, the code is a bit more verbose, but we get a lot more freedom and granular control in return. For example, the JavaScript API only allows you to access certain predefined directories like home and downloads. But here, you can run arbitrary Rust code at native speeds, which is extremely powerful. Just to recap, this is the final finished application. The front end is written in Angular, and that has been transformed into a native desktop application by using Tauri. If the user clicks Rust to this question, Ferris will be very happy, but if the user clicks C, Ferris will be very mad and threaten to delete one of your home folder directories or files. And you can call him on his bluff. It won't actually delete the folder or the file, because if we did that, this would be malware. But if you wanted, it wouldn't be too hard to extend this to actually delete or maybe rename the file to something else. We explored two ways of getting Ferris to find and select a random file or folder from the user's home directory. The first way was using the Tauri's TypeScript API, and we discussed how that was really convenient but had some drawbacks in granularity. We also discussed how security measures are implemented and how we have to explicitly allow certain APIs to be used. The second way was for us to code a custom backend function in Rust here to actually do the same functionality as we implemented in the first one. But in this case, we are running in the core process, so we didn't need to do any of the security stuff. It is important to recognize that Tauri is still very new compared to Electron. Electron is already being used by big companies, has better community support, and has more features. If you need to do something with Electron, chances are that someone else has already had to do the same thing and have probably asked it on Stack Overflow. That said, Tauri is growing fast and is well on its way to reach feature parity with Electron. Recently, the beta for V2 of Tauri was announced, where it, among other things, introduces mobile as a compile target, revamped IPC, an access controllers-based permissions model, and several new APIs like the context menu API. Of course, they're also paying to get a security audit done for the entire Tauri repo, just like they did for V1. I've included links to the resources I used personally when I was learning Angular and especially Rust for this project, so feel free to check those out. And I've also linked Tauri's documentation there, so if you want to, find out if Tauri has a certain API you are thinking about, feel free to have a look at that as well. I really do hope you found this topic as interesting as I did, and have a great day.